This panorama by Perseverance rover looks out at the expanse of Jezero crater's river delta. The delta formed billions of years ago from sediment that an ancient river carried to the mouth of the lake that once existed in the crater. Aeolian sand dunes can be seen running along the base of the delta, and the hills visible on the distant horizon to the far left, about 3.8 miles away from the rover, are actually part of the rim of Jezero crater. The peak of the delta remnant to the right center of the image is about 920 feet away, and the peak of the hill right is about 950 feet away. The portion of the delta farthest left in this image, visible directly below the crater wall, is the area where two channels, Cape Nockshak and Hawksbill Gap, can be found. After investigating the area, Perseverance then ascended to the top of the delta via one of these two channels. This picture was taken far north of the equator on Mars, just 2 days after the winter solstice when the sun was just a few degrees above the horizon. Sand dunes are moving across this landscape from top left to bottom right. Winter frost covers the colder north-facing half of each dune, but not the warmer south-facing half. The frost here is a mixture of carbon dioxide ice and water ice and will disappear in a few months when spring arrives. This is Victoria Crater, an impact crater located in the Meridiani Planum region on Mars. It is roughly 800 meters wide and 75 meters deep. The crater retains a 5-meter raised rim consisting of 1 to 2 meters of uplifted rocks overlain by 3-meter ejecta at the rim crest. Along the edges of the crater are many outcrops within recessed alcoves and promontories. The foreground and middle distance in this panorama shows a geologic scene dominated by eroded remnants of a finely layered ancient sandstone deposit. Curiosity rover has traveled through the terrains here that are dominated by water-lain sedimentary rocks, some of which have contained minerals like clays that attest to the ancient presence of water. However, the rover also crossed into very different geology while climbing onto the Knockluft Plateau in the area. The sandstone here appears to be dominated by thick layers of wind-blown sand suggesting that these deposits formed in a drier epoch. These rocks resemble the types of rocks that a dune field like the Bagnall Dunes would form if buried. A portion of the rim of Gale crater fills the horizon in the center of the image, with upper Mount Sharp on the horizon at right. As spring turns to summer in the northern hemisphere on Mars, unusual streaks of clouds form high in the atmosphere around sunset. These noctilucent clouds are high-altitude water ice clouds that nucleate around meteor smoke or the vaporized remnants of small meteoroids that impact Mars's atmosphere. These clouds are very thin and are only visible around sunset when the sun has set on the lower atmosphere. This image, taken by Perseverance rover's Mastcam Z, shows a region of the Jezero Delta where Perseverance drilled and collected many rock samples. Curiosity Mars rover recorded this video showing the passage of 12 hours of a day from 5:30 a.m. to 5:30 p.m. on Mars. The video shows the rear Hazcam's view as it looks northwest down the slopes of Mount Sharp to the floor of Gale crater. The rover's right rear wheel is visible along with the shadow of Curiosity's power system. The first few frames have many hot pixels. Additionally, the brightness of the afternoon sunlight saturates the Hazcam's sensors, giving the sun a distorted blob-like appearance. As the signal bleeds across the pixels, it also creates rows of white pixels that spike out from the sun. Sitting near the rover's warm power source, the rear Hazcams are more susceptible to sensor noise. In this video, excess heat creates artifacts that are seen throughout the clip. A small black artifact that appears at the left midway through the video resulted from a cosmic ray hitting the camera sensor. This panorama shows a boulder field on a mountain at J0 crater. Analysis by Perseverance rover's SuperCam and MastCam Z instruments indicate that the light-toned boulder with dark speckles near the center of the image is composed of the mineral pyroxene, similar to some boulders the rover has encountered elsewhere in J0 crater. In terms of the size, shape and arrangement of its mineral grains and crystals, and potentially its chemical composition, the rock is different from any of the rocks the rover has encountered before. Some scientists speculate the minerals that make up the rock were produced in a subsurface body of magma that is possibly exposed now on the crater rim. Others wonder if the boulder, which stands about 18 inches wide and 14 inches tall, had been created far beyond the walls of J0 and transported there by swift Martian waters eons ago. This view of the twilight sky and Martian horizon taken by NASA's Curiosity Mars rover includes Earth as the brightest point of light in the night sky. Earth is a little bright speck left of center in this image, and our moon is just below Earth. Curiosity used its mast camera to capture this scene about 80 minutes after sunset on Mars. A human observer with normal vision, if standing on Mars, could easily see Earth and the Moon as two distinct bright evening stars. This is Korolev crater, a breathtaking ice-filled impact crater located in the northern lowlands of Mars, south of the dune-filled Olympia Unday that encircles part of the northern polar cap. Korolev is 81.4 kilometers in diameter and contains about 2,200 cubic kilometers of water ice, comparable in volume to the Great Bear Lake in northern Canada. The crater rim rises about 2 kilometers above the surrounding plains, and the crater floor lies about 2 kilometers below the rim and is covered by a 1.8 kilometer deep central mound of permanent water ice up to 60 kilometers in diameter. The ice is permanently stable because the crater acts as a natural cold trap. The thin Martian air above the crater ice is colder than air surrounding the crater. The colder local atmosphere is also heavier, so it sinks to form a protective layer, insulating the ice, shielding it from melting and evaporation. Recent research indicates that the ice deposit formed in place within the crater and was not previously part of a once larger polar ice sheet. The ice in the crater is part of the vast water resources at the poles of the planet. This view looks to the west on the base of Mount Sharp, which lies to the left of the scene. The image shows sets of sandstone beds, all inclined to the south, indicating progressive build-out of sediments toward the mountain. These inclined beds are overlain in the background by horizontally bedded fine-grained sandstones that likely represent river deposits.